go over an example of an operator in R3 that is not linear. So here we have L is equal to x2 squared, x3, and then x1. And first let's check the condition if the zero vector doesn't exist. If we do x1 or x is equal to 0, 0, 0, L of x is going to give us back 0, 0, 0. So this condition exists, and we want to check whether our two conditions that I mentioned in the previous video are valid. And if they are valid, then we have a linear operator, and if they're not valid, then the operator is not linear. So I'm just going to write it above. Our first condition is L of f plus g is equal to L of f plus L of g. Our second condition is that L of some constant k times f is equal to k times L of f. Okay, so let's try this out with two different vectors, a and b, where a is equal to a1, a2, a3, and b is equal to b1, b2, b3. Let's test out the first condition. We get L of a1 plus b1, a2 plus b2, a3 plus b3. And we want to check if that's equal to L of a1, a2, a3 plus L of b1, b2, b3. So what does this mean? If we apply the operator L to we want to get our first row. So the first row is defined as x2 squared. So we're going to take, this is right here, let me see if I can highlight it. That is x2. So we're going to do x2 squared. Sorry. x2 squared, which will be a2 plus b2 squared. The next row will be x3, and x3 is right here. So a3 plus b3, and then our last row is defined by x1, which is right here. So a1 plus b1. And we want to check if that's equal to this right-hand side. So let's do the same thing and apply the operator L to a separately and to b separately, and then add them. If you do that, you should get, well, we're going to look at a2 squared. So it's going to be a2 squared, and then a3 and a1 plus b2 squared plus b3, or sorry, not plus, b3 and then b1. And these two added together, and already you should tell that they are not equal, right? Because you'll notice that this row and this row, they're equal to the left-hand side and the right-hand side are equal, right? a3 plus b3 is equal to a3 plus b3. a1 plus b1 is equal to a1 plus b1. But the first row is not equal. a2 plus b2 squared is not equal to a2 squared plus b2 squared. And this is just something you should know. Like, you can test it out, but whatever's inside the parentheses squared, it's not going to be the same as, applying the square to each separate term and then adding them. That's not how it works. So for example, like if you had, say, 2 plus 5 squared versus 2 squared plus 5 squared, this is 7 squared, which is 49, and this is 4 plus 25, which is like 29. They're not the same, right? So because our left-hand side and our right-hand side aren't the same, then this condition fails. We don't need to check B. If you wanted to, you could check B, but even if B was valid, it would still, our vector L, or operator L, will not be a linear operator because it already failed one condition.